There are some agents of change associated with metamorphism, and we know what they are, temperature, pressure, but I'll go through them in a little more detail. So higher temperature implies that new minerals become stable. You change the equilibrium mineral assemblage. Higher temperatures also enable you to get over boundaries, barriers, kinetic barriers associated with the change of minerals. And higher temperatures also encourages recrystallization of the rock. So most of the change in metamorphism occurs on increasing temperature, on heating. And why is that? Well, that's prograde metamorphism, but the retrograde metamorphism, dropping the temperature, then you have kinetic barriers that inhibit further change in the rock. Other agents of change, higher pressures. Again, higher pressure means greater depth of burial and a different equilibrium assemblage of minerals. Again, the base of the continental crust is around 1 GPa, and if a rock has been buried as deep as the base of the crust, we typically call that high pressure metamorphism. If the rock is carried down in a subduction zone to yet greater depths, it's called ultra-high pressure metamorphism, and minerals such as coesite and diamond can be produced in ultra-high pressure metamorphic provinces. And so these coesite and diamonds in metamorphic rocks suggest that continental crust can be carried down over 100 kilometers into the mantle, where they can form an equilibrium, and then they are metastably preserved when the material isostatically rebounds to the surface. Other agents of change, well, one of them is deviatoric stress. Well, what does deviatoric stress mean? It means that pressure forces are different in different directions, and that leads to deformation of the rocks. And we describe this as a foliation, which is a directional fabric in the rock. And let me illustrate how you develop foliation in a rock. If you imagine a spherical rock exposed to isostatic pressure that is the same in all directions, I illustrate that with arrows pushing in on this sphere, and all the arrows are of the same length. However, if due to collisional forces in plate tectonics, one set of arrows becomes larger, there's a larger force pushing on the rock in that direction, the rock can strain to compensate for that deviatoric stress. It strains by elongating along what we call a strain ellipsoid, and it elongates in the lowest stress direction. It shortens in the high stress direction. Foliation develops in the rock, and that's linear features that are perpendicular to the high stress direction. Other agents of change. Well, an important agent of change is any fluid flowing through the rock. And water and carbon dioxide are the principal fluids that you find flowing through rock masses. And they are both reactants and products of chemical reactions. They go into and they come out of various chemical reactions. They also transport other chemicals as they move through the rock, and they enhance reaction rates when they are in contact with mineral surfaces because they lower kinetic barriers. We know that rocks contain fluids of water and carbon dioxide because we can find inclusions in minerals that have been metamorphosed, and here's a photomicrograph of such an inclusion. It contains water, and as it's cooled, the mineral constituents have precipitated out, and we have a large square halite crystal, a smaller sylvite or potassium chloride crystal, and some other crystals that are unidentified in this example. The bubble there is vapor phase of water.